So we're on page 8 where we've been working for a couple days now. We already did gravity erosion last Thursday. We did wind erosion. On Friday, we are going to finish up page 8 here by talking about glacial erosion today. You still owe me one more?
Those are both.
You only owe me 2 more? Just these 2? Okay. So anyway, we're doing glacier erosion today. What, Remy? I wouldn't, but that's up to you. Moving on. So today we are starting with glacial erosion. And we're gonna start with on Friday at the end. Have you heard a word I've said the whole time I've been talking?
I do myself.
Okay. So anyway, as I've said for about 3 times now, we're starting glacial erosion today. We talked about on Friday how glaciers are made. We talked about how snow piles up, doesn't melt, turns to ice, and we get glaciers. And through the weight of the snow alone, it causes the glacier to spread out a little bit. Here's another example of a glacier. So here we have what's called an alpine glacier. Called alpine, like the alpine means mountains and things like that. So this is a glacier that comes from the mountains. I think most of you guys know the tops of mountains are cold. Okay, not all of them, but really tall mountains, they do get really cold at the top. So any precipitation that falls on mountains is typically snow. So the snow piles up here at the top of the mountain and the glacier will eventually slide down the mountain is the gist of it. So in the end, it really comes down to gravity moves the glaciers, whether it's downhill or just the weight of the glacier pushing the glacier out to both sides like we talked about last week. So we did already talk about that. So how do glaciers actually erode? So it is often, let me just go to this video. It is often said that glaciers act like a bulldozer. What can bulldozers move? Everything. Yeah, they move dirt, but a bulldozer is strong enough to move basically anything that's in its way. It moves the dirt, it moves the big rocks, slow and steady. A bulldozer might not be the fastest piece of equipment, but it does move slow and steady. It moves everything around it. So I do have a video kind of showing how a glacier acts like a bulldozer and picks up and moves sediments. So we're gonna go to, is this it? I think it's this one. Oh, one more time. So I skipped ahead and we're just gonna watch it from where the bulldozer part is.
Sometimes called nature's bulldozer. Just like a bulldozer, glaciers shape the land in 3 ways. Firstly, glaciers pick up material. We call this erosion. Water flowing along the bottom of the glacier seeps down into the rock below. When it freezes, it opens up the cracks in the rock. This is known as freeze-thaw
We
weathering.
call it frost wedging.
Then, as the glacier flows downhill, pieces of rock.
So before it keeps going, this is frost wedging. This is how frost wedging broke the sediments. We talked about this last week. The water gets into a crack, the water freezes, expands, makes the crack bigger. And what it really does is separates a piece of sediment, or a boulder in this case, so that the moving glacier is able to pick it up and take it with it. Just like I kind of mentioned how plows would pick up and move those sediments that got picked up. So here, this glacier is really just acting a lot like a plow does.
Come loose, and the glacier pulls them along with it. We call this plucking. Ouch.
Plucks it up and moves it
These
somewhere.
rocks and stones scrape along the glacier bed like sandpaper, taking more rocks and stones along for the ride. This is called abrasion.
You can see how those rocks are.
Secondly, the glacier transports this eroded material as it flows downhill. Some of it is hidden inside or at the base of the glacier where it can't be seen, but sometimes it is transported on the top of the glacier. This is why glaciers often look dirty. As the glacier flows down a mountain, it gets warmer and starts to melt. Just like a snowman, anything which cannot melt is left behind. As the glacier melts, the rocks and stones fall to the ground. We call this deposition. By now, this material is a tasty mixture of rocks, stones, sand and clay, known as glacial till. The melted ice turns into meltwater and flows downhill to join a river or lake. Today, glaciers only exist in the coldest parts of our planet. But during the last ice age, glaciers existed in the UK too. Although the ice has melted, they have left behind some awesome scenery. As our planet warms up, many of our amazing glaciers are melting fast. So grab your walking boots and head to your nearest glacier while there's still time to see nature's bulldozer in action.
Yeah, we'll go see some glaciers in England on our field trip. So yes, they talk a little different than we do, but I think you got the point there. So one thing I want to point out is, like she just said here in this part, a little bit further, is even though the glaciers do not still
Today, glaciers
exist,
only
there
exist
is
in the
evidence
coldest
that
parts
there
of our
was
planet.
glaciers
But during the
around,
last
and that's
ice
what we
age,
need to focus on today. Is if you see something like this valley here, you need to realize that a glacier shaped that valley. What do you notice about this valley? It is a valley. So there's a low spot with two high spots on either side of it. If you had to make a shape out of this valley, this should look like a U to you. So a U to U. So if you notice, it doesn't come down to a point. Glaciers, what they do is they take these valleys and they bulldoze them to look more like a U shape. So even though there's no glaciers in the United States right now, we can see evidence that the whole country practically was covered in glaciers. And one example are these U-shaped valleys that we'll find all over the place. All right, so let me go back to the PowerPoint. So like I did last week, I'm going to have a bunch of pictures, then we're going to get some big ideas, then we're going to do a sketch. The only thing different today is then I'm going to let you do your homework. So those of you who are here, you'll probably get most of your homework done here in class. Anybody who's not here will have to do that on their own time. What? No, you got to retake the test still. Okay, well then you don't bother. Okay, so first thing that she mentioned, one of the things that she mentioned in the video is, she said something about a tasty mixture of everything that the glacier was carrying. Yeah, they must talk a little bit more happily than we do. I don't know. I've never called it a tasty mixture, but you get the point. Yeah. Glaciers, they pick up, just like Sam said at the beginning of class, just like a bulldozer does. They pick up everything that's in their way. But then when they melt, just like that melting snowman, what'd you say? Yeah, they make a tasty mixture. Just like when that snowman melted in the video, it left behind the hat, the scarf, the eyes, the corncob pipe. When a glacier melts, it leaves behind whatever was in it as well, just like the snowman. So just like gravity erosion, you will often find a mixture. Now we call this unsorted sediments. Again, unsorted means a tasty mixture. When it comes from a glacier, it is called glacial till. So a pile of unsorted sediments is just glacial till. We will see, you'll start to see these unsorted sediments once the glacier starts to melt. So here you can see that a glacier had been coming down this mountain, but it stops here and it starts to melt. Why does it start to melt down once it gets down to the bottom of the hill? Bottom of the mountain. Why does a glacier melt when it gets down towards the bottom? Yeah, because it's warmer down there. So wherever it starts to get warmer, in this case at the bottom of the mountains, or when there was a whole ice age, places closer to the equator would be where the glaciers would start melting. So when they start melting is when they start leaving behind whatever they were carrying. So you'll find these piles of sediments. In this case, they're called moraines. Anytime you see a pile of unsorted sediments, it's often dropped off there by a glacier. And these are called moraines. It's just a hill of unsorted sediments. Again, you don't need to know exactly what a moraine is. We're going to get to this part in our notes though. So here's some other things a glacier can do. And I do have, I'm not exactly positive how to pronounce this first one with the A, but these are creeks and horns. It's just these weird shaped parts of mountains. They're caused a lot by that ice wedging and then the glacier pulling and plucking the rocks off of them. So just like last time, do you need to know exactly what these are? No, but you need to know that these words are associated with glacial erosion. So we're going to put them in our big ideas in a minute. Here's again what these could look like in mountains. So you have these different weird shapes up in the mountains that all are created by glaciers. Here's just some more pictures of them and some more. All of these shapes were shaped out by the glaciers. So that one's gonna, again, glaciers ripped off each side of those. Here's an example of one of those U-shaped valleys, but this U-shaped valley got filled with some water, then it's called a fjord. So a U-shaped valley filled with water is a fjord. There's some more examples of those moraines. These are piles of sediments that the glaciers left behind when they were melting. When glaciers melt, which direction, what happens to them when they melt? Actually, let's go there. When a glacier starts to melt, what happens to it? Does turn into water. What happens to the size of the glacier? It shrinks. So this glacier that is now only over here on the left used to be here. In fact, what's called a terminal moraine is where it stopped. This is as far as it ever went to the right on this screen. When a glacier starts to melt and it's shrinking, scientists say that it's retreating. When else have you heard the word retreating? Wars. So a glacier, a lot like an army, a lot like during a war, it really creates havoc on everything that it's touched. So when this glacier is moving forward and backwards, they use war words. What's it called when an army's going forward? Advancing. So just like an army, when this glacier was getting bigger and coming over here to the right, they'd say the glacier was advancing. And just like an army, when it goes back to where it came from, when a glacier starts to melt, it's called retreating. So those are two words that I don't think we have to write down because I think you know what they mean from advancing and retreating from social studies, going forward and going backwards in a war. So we won't write those down. Here's another example of things that are created by glaciers. They're called drumlins. Again, they're these funny shaped hills that are just full of unsorted sediments. And these sediments, they make these weird shaped hills. They kind of look like the back of a spoon. And it does show which way they're moving. So there's a blunt end and what they call a tapered end. With glaciers, they're going the direction of the taper, kind of like an arrow. Yeah, that's what it's supposed to look like. Finally, there's some things called kettle lakes. You guys ever heard of kettles? Like kettle corn. Can you guys all picture them making kettle corn at the fair? What's a kettle? What can you describe what the kettle looks like that they're making it in? Big, what shape? Roundish. What are the sides look like? A circle, straight up and down. So a kettle is different than like a frying pan. Do you guys know a frying pan is really shallow and has sides that kind of go out just a little bit, but they do go out. Whereas a kettle is deep and typically steep sides. So it's different than a frying pan. These lakes are the same idea. Notice their circular shape. Unlike like some things that we're used to where you walk in and it gradually becomes deeper, a kettle lake is almost in and straight down. These are created, here's kind of what it would look like. So we get a big block of glacial ice that kind of broke off. And it sits on the ground and it sinks in and gets covered with the dirt from the glacier. But eventually it melts and you end up with this situation. And again, that looks like the kettle from Kettle Corn, circular, steep, deep sides. And you're left with these weird lakes that are just round. They're called kettle lakes. We get these are some of my favorite things. This is Central Park, New York City. So that's New York City in the background. Got all this green grass and some random ginormous boulders. How do you think a giant boulder got put in the middle of Central Park? Aliens, right? A crane. Yeah, they didn't do that. Glaciers. So you're right. The only thing that would be strong enough to move a big boulder would be a crane or some aliens or a bulldozer or a glacier. It's not you, I promise. You've seen them do it? I'd need to see proof live in person.
Here.
Anyway, these giant boulders, they're called erratics.
Yes.
Have you guys ever heard of the word erratic used in a sentence before? Okay, Sam's very erratic. Okay, Alex is, Remy is, Phoenix is. You guys are all a little erratic. You're not? Yeah, right. I don't think so. Anyway, my husband, we've already talked about him. Guys, remember how we talked about not talking to each other? Okay, we're going to start enforcing that again. Yeah. So my husband, as a trooper on the thruway, he always got called to erratic drivers. What was he getting called to? Drunk drivers. But he wasn't always called to drunk drivers that were being called in. How does an erratic driver behave? Crazy. They behave erratically, but I would describe it as crazy. Really bad drivers. Erratic drivers don't belong on the road. Now you always say drunk drivers is always the first thing, and yeah, they are typically erratic drivers.
Actually, drunk for a second.
But my favorite was a story he used to tell about this little old lady. And they used to get called to this little old lady multiple times a month. She literally, he's like, every time we pulled her over, like she got literally called in once because somebody thought she was dead behind the wheel because she was like slumped over, not going so slow on the thruway that she was going to get hurt because she was going so slow. And they knew her name. Like they knew her, they knew the car. So when they would hear the car get called in, they're like, oh, I can't remember her name, but oh, it's Ethel again, whatever. And she was a little old lady, and she literally had like bluish white hair that stuck just over the steering wheel. And they'd get called in because she was such a bad driver. But you're right, old ladies, drunk drivers, old men too, for that matter, or a bunch of you teenagers. I've seen some of you guys drive in the parking lot. You guys are erratic. Crazy drivers don't belong on the road. Well, that's what's here too. These are crazy rocks. They don't belong where they are. One thing that's crazy about these rocks is New York City, the rocks under New York City, you guys know bedrock from Minecraft? The rocks underneath the ground. Okay, bedrock in New York City is sedimentary. But this rock right here is igneous. So we've got this random igneous rock on top of sedimentary rocks. Do you think this igneous rock came from New York City then? No, because New York City is made out of sedimentary rocks. And we've got a random igneous rock sitting on top of it. So it was shipped in. Legit, it was shipped in, except for the transporting ship was a glacier. Brought it somewhere from probably Canada. Broke off a rock in Canada, where there was igneous rocks around, and dropped it off here in New York City. What? So the fact that it's one little, so I often say to my kids when they're crabby, if you think everybody else is the problem, it's more likely you. So if everybody else in the house you think is crabby, but it's every single human, and it's more likely you're the one that's crabby and not being tolerant of the rest of us being normal. But see, oh no, my kids are definitely not, they're not as, I mean, they're just as normal as you guys. but none of you are super normal either, sorry. Okay, so what I'm getting at, so to answer Ken's question, no, New York City isn't the weird part, because again, the whole city, the rest of the city is the same with only this one weird thing here. So having one weird thing, that's the weird thing, everything else would be normal. So these are just called erratics, and you'll find them all over the place. You can probably even find some of them around here. Random huge rocks that don't belong with the rocks they're sitting on. Yeah, parts of it, I believe. Right? Or did we decide that that one wasn't?
Rox, is that the one in Olean?
There is one in Olean. There's a couple of them. Yeah, it's been a while, but in theory, yeah, Rock City doesn't belong there. We should, in fact, we did 10 years ago. Actually, 12 years ago. I know that for a fact, huh?
Rock City, what is Rock City?
Rock City is a little, so we went to Little Rock City. I don't think it was the one in Olean.
No.
I don't know. Mr. D drove, I didn't, so.
Yeah, it was close.
But anyway, it's a bunch of rocks that just don't belong.
What did she
Walked around. Okay. So here's a couple more examples, just random rocks that don't belong where they are. Ooh, these are some of my favorites. What did glacial erosion look like after a glacier goes through? The rocks that were in there. So you remember all the rocks that the glacier picked up? Act like sandpaper on the ground and create these scratches. So can you see how there's like actual scratches in the ground? That's cool. This reminds me of when my kids used to help my husband wash a car. You guys big on keeping cars clean and pretty looking? Okay, some of you are, I'm not, but my husband is. And you see, hate when the kids would help because they were bad with the sponges. Why were you not allowed to put a sponge you're washing your car with on the driveway? Picks up dirt and sand and little rocks, right? And then you go and you use that sponge on your car and it scratches it. Glaciers act the same way. So remember that picture with all the rocks that the glacier was carrying? Instead of remembering, let's go back and look. A glacier, oh, of course it was in the video. A glacier. So remember all. So remember this picture in the movie. So see all these rocks in the bottom of the glacier? And when this glacier slides down the hill, those rocks are going to act like the rocks in the sponge, and they're going to scratch the ground underneath it. And that creates these really deep scratches. Yeah, really deep. Guys, remember how we said we're not talking to each other? So they make these scratches. The bottom of the glacier has all those rocks in it and scratches the surface. See how deep these scratches are in this picture? Yep. Why do you think this glacier made deeper scratches than this one over here?
No, they're different glaciers.
Different glaciers. What was different about them? What'd you say? This one could have had bigger rocks to make bigger scratches. What else would need to have happened? One could be more downhill than the other. What would happen if a glacier was more, and I'm guessing you mean more downhill like this, like more steep? Is that what you mean? What would happen to a glacier if it's going down a steeper hill? It's going to go faster, just like a sled on a hill. The steeper the hill, the faster the glacier is going to go. Think of making the scratches on the car. What would the kids have had to done to make bigger, deeper scratches? Okay, one would be bigger rocks, and Remy already mentioned that. A lot of pressure. How would a glacier put more pressure than other glaciers? What? Bigger glacier. A bigger, heavier glacier is going to be pushing down more than the lighter glacier. So this one would have been a bigger glacier, more pressure, bigger rocks pushing down on this one compared to this one. This one's just going to act like sandpaper. This one's going to gouge out the rocks. See? You made a glacier? So here's some more examples of those scratches. All right, so some big ideas for glaciers. Here's what I want. So yes, it is 5 full bullets. I would like you to write these. We're right on page 8 in the big ideas. Oh, good. Glad I could make your day worthwhile. So glaciers move by the force of gravity. Yep, that's what we said. Gravity is the driving force of all erosion. Yep. So they move anything in their way. They pick up any size. And again, that's called plucking. As they melt, they drop off any sediments they were carrying, just like a melting snowman. They drop off whatever's in them. Are the sediments going to be sorted or unsorted, by the way? They drop off sediments as they move, sorted or unsorted. Why are they unsorted? Because it's random. Whatever they were carrying is what they drop off. So please add that. Unsorted. They can move whatever's in their way. So absolutely moving a tree. They could, if a glacier was coming through, the school is out of luck.
That'd be awesome. It would be great.
Okay, so glaciers only move like a centimeter to a day, if that. So we're good. We probably would see them coming.
Yeah, but we watch that in 0.5.
Listeners, I found Little Rock City. We were right, it wasn't through glaciers. It was when mountains were being built and the large rocks left over are the more resistant material that was left behind.
Okay. So they,
Sorry.
no, thank you. So they were slightly different. The Little Rock cities, not quite the same. It's the ones that were strong enough to be left behind after everything went through.
And if you go to Allegheny State Park, they have, I think it's called Thunder Rocks.
Yeah, that was fun.
Very similar, when the Catskills were being made. This is the sediment left behind when the Catskills were being made out east, so these large boulders drifted west as it was being eroded. So, not glaciers.
Last thing that is up here. Created most of our local landscape. Now, while we don't live in any of those really tall mountains and we don't have any of those fancy shaped ones, we do have the hills and the valleys left behind as the glaciers plowed through our area. One other thing that we have left behind from glaciers is our gravel pits. You guys know all the gravel pits around here? Okay, not quite how we would ask, but a gravel pit is a pit filled with gravel. We've got, I know there's one over off of you can see it from Genesee Road. It's a big hole in the ground where they're digging up gravel and they're selling gravel. They're making money by selling rocks. Is it? Okay, where'd that gravel come from? And where did it come from? Glaciers. That gravel is a bunch of unsorted sediments that the glacier dropped off right here in a bunch of places in Pioneer. Well, that's because you're hitting the water table, but the glaciers dropped off all the sediments that they are pulling out of the gravel pits. So right here is a place where the glaciers stalled, melted a little bit and just happened to drop off a bunch of those rocks right here in Pioneer. Pioneer area is making money off of glaciers still today. So I think that's pretty cool. Two more things. Let's do our sketch. What's some things you think we should sketch here? Now, see, you might think that's what I want, but I want a feature that the glacier creates. One thing I'm going to create is a U-shaped valley. I'm going to label it U-shaped valley. I will guarantee you the Regents will ask you either about a U-shaped valley or a V-shaped valley this year. We've only talked about U so far, so U-shaped valleys are created by glaciers. I think that's honestly enough for a picture. One more thing we just got to flip over to talk about Finger Lakes and the Great Lakes. You heard of the Finger Lakes before? Where are they? Over there. That away. The Finger Lakes are right here, kind of in the middle of New York State. So Buffalo's over here towards the east side, or I'm sorry, towards the west side. Finger Lakes are over near Rochester-ish. Lake Erie's right here. No, Lake Erie's not a Finger Lake. That's a Great Lake. Great Lakes are that way. Yeah, that-ish way. Finger Lakes, aren't they? Anyway, they're right here, look. Do you see why they're called Finger Lakes, first of all? Because you should see that those kind of look like fingers. Now, the fact that they go north to south-ish, yes, they're off to the sides a little bit, but they're pretty much north to south, also talks about which way the glaciers were moving. So how this happened is the Finger Lakes were originally valleys that rivers were going through. And then a glacier, just like if we took a bulldozer and bulldozed through this valley, it made more of that U shape. And then the glacier filled it in and it pushed out the sides, changed the shape of the walls. Then the glacier melted. And what happened is the ends got dammed up with those unsorted sediments and they filled in with water. That's the gist of how, so again, it went from a V-shaped valley to a U-shaped valley that got filled with water. Now don't write this next slide. So it was already a river valley. They got modified by glaciers. And then when the ice retreated, again, went backwards, it left behind the dammed up stream valleys and they got filled in with water. And the fact that those lakes go north to south show that that's which way the glacier was moving. So what do I want you to write there on page 9 about Finger Lakes? We'll keep it simple with these 2 bullets. Glaciers widened, deepened, and accentuated existing river valleys. It's not kind of, that's exactly what was happening. Started in the north where it was cold and worked its way south. All right, and one more thing, and that's the Great Lakes. So the 5 Great Lakes. So yes. Accentuated. So like it showed off, like it made it more pronounced. So like people will put makeup on to accentuate their eyes or their cheekbones or things like that. Now the Great Lakes like Erie, Ontario, Michigan, Superior, and I'm missing one, Huron. These are the Great Lakes. These were formed at the end, again, don't write all this. Formed at the end of the last ice age. So in terms of the earth, they're pretty new. So about 10,000 years ago. They actually carved out the bedrock this time, and the glacier water filled up their basins that they created. And fun fact, the lakes contain approximately 20% of the world's fresh water. So our little corner, Lake Erie, Lake Ontario, and the other three hold 20% of the world's fresh water. It is pretty impressive. So what I want you to put in your notes about the Great Lakes is the ice carved out the lakes, which was then filled with melt water. Yes, so it is called melt water. I did not mention that melt water is what is the fancy name for water that's coming from a glacier. Yes, it's just melted water, but it's called melt water. So what do you need to do for homework? It does say pages 9 through 13. It sounds like a lot. It's 22 questions, but I would like you to skip question 10. It's on page 11. So you can go cross that one off. We're not going to know that one until next chapter. So you have 21 questions for homework. Yes, I do expect you to do homework over your break, because remember, it's not a break. It's school days. You're just not have to come. So pages 9 through 13.